Now we'll look at another relationship between two variables represented graphically. In this case, we'll look at the behavior of a hamburger customer, Bob, and we'll look at what Bob does when the price of hamburgers changes. I'm going to now look at a data set that represents the price of hamburgers and the quantity of hamburgers that Bob consumes every week. Let's look at the relationship between these two variables. When the price of hamburgers is $5, Bob doesn't buy any. They are too expensive. Even if the price drops down to $4.50 per hamburger, Bob still doesn't buy any hamburgers. If the price drops down to $4 per hamburger, Bob decides to treat himself to one hamburger a week. If the price falls to $3.50, Bob buys 2 hamburgers each week, and so forth. Every time the price of hamburgers drops by 50 cents, Bob decides to buy 1 more hamburger per week. And finally, if hamburgers drop down to a price of $1 apiece, Bob buys one every day. That is 7 hamburgers per week. Let's now represent this relationship between two variables, price and quantity, in a graph. First thing that I'll do is I will draw 2 axes and calibrate them. Here are my axes for this particular problem. The 2 variables that I'm interested in analyzing are the price of hamburgers and the quantity of hamburgers consumed per week. So let me go ahead then and calibrate my axes. On the horizontal axis, I'm going to represent the quantity of hamburgers consumed by Bob every week. So as I increase my distance from the origin, that is the place where the axes intersect, as I increase my distance from the origin horizontally, Bob is buying more and more hamburgers every week. And those numbers are represented here, 1, 2, 3, 4, and so forth. On the vertical axis, I'll represent the price that hamburgers sell for. The sale price of hamburgers is represented on the axis here, increasing $1, $2, $3, $4, and so forth per hamburger. So on the vertical axis, we have price per hamburger. On the horizontal axis, we have hamburgers consumed per week. If you look in the box, you'll see the information that we were just looking at about Bob's behavior. In the box, you see the number of hamburgers that Bob buys at different prices. I'm going to now transfer that information that's in the tables into a picture here, a representation of the relationship between price and quantity. Let's start then with a price of $5, Bob buys no hamburgers. At a price of $4.50, Bob also buys no hamburgers. So we have points here that are actually on the axis. That is, 0 hamburgers are purchased. So Bob is behaving in a way that gives us points that are on the axis. So here's a price of $4.50 per hamburger and no hamburgers consumed in a week. Now, when the price drops down to $4 per hamburger, Bob actually buys a hamburger. Now we have a point in our space that's right here, 1 hamburger at a price of $4. So that gives us a dot right here to represent Bob's behavior. The coordinates of this point are 1 and $4. If the price drops down to $3.50, so we'll be looking at a price that's right here on the vertical axis, Bob buys 2 hamburgers per week. So now we have a point that looks like this. At a price of $3, Bob buys 3 hamburgers per week. So now we have a point that looks like this. At a price of $2.50, Bob buys 4 hamburgers. So that lets us drop down to another point like this, $2.50, 4 hamburgers. In each case, I'm finding a pair of numbers like $2 and 5 hamburgers, and I'm putting a dot at the horizontal vertical coordinates. 6 hamburgers at $1.50, so find the $1.50 point, and 6 hamburgers, put a dot there. And finally, we get 7 hamburgers when the price drops down to $1, and that gives us a point like this. So these dots represent Bob's behavior. That is, the quantity of hamburgers that he consumes as the price of hamburgers changes. Now we can connect the dots in this diagram and form the demand curve for Bob. That is, we can draw a line that represents the relationship between the price of hamburgers and the number of burgers that Bob consumes in a week. Let me go ahead and do that. I'll draw a line here that connects all of these dots. And it looks like this. And this is Bob's demand curve. We can even put a label on it, say label it with the letter D, to let us know that this is Bob's demand for hamburgers, the relationship between the price of burgers and the quantity that's consumed. Now, if I want to, I can write down the formula for this demand curve, and I'm going to go ahead and do that. Now, I knew the formula before we started because I used the formula to form the tables. The formula for Bob's demand curve is this. The price, that is, the vertical axis variable, is equal to $4.50, which is the price at which Bob will buy no hamburgers, minus 50 cents times the quantity of hamburgers that Bob buys. That is, for every additional hamburger that we want Bob to buy in a week, we have to lower the price of a hamburger by 50 cents. This is the relationship between quantity and price for Bob. And that is the formula for this line. Now, if that takes you by surprise, remember from your algebra class that if we have a variable that's measured on the y-axis and another one that's measured on the x-axis, that the formula for any straight line is equal to this. The y-axis variable is equal to a plus b times x, where y is the variable that we're measuring here, in this case, price. X is the variable that we're measuring here, in this case, quantity. A is the intercept, or the height here on the vertical axis when the x variable has a value of 0. In this case, Bob is buying 0 hamburgers when the price is $4.50 per hamburger. A represents the intercept, and in our case, the intercept is $4.50. B represents the slope of the line, the rise over the run. And in this case, the slope is negative 50 cents. For each additional hamburger that we want Bob to buy, we have to lower the price by 50 cents. So B, in this case, is negative 50 cents. Let's take a moment and remind ourselves about the slope of a line. The slope of a line is equal to the rise over the run. And the rise over the run is the same thing as saying the change in the y variable, that is the rise, the upward movement in the graph, delta y, which in economics stands for the change in y, divided by the run, which is the horizontal movement, or the change in x. So if we want to know the slope of a line, we look at the change in the horizontal, or the change in the vertical variable, divided by the change in the horizontal variable, the rise over the run. Let's look at an example here. If we increase the price of hamburgers by 50 cents, say from $2 up to $2.50, Bob's behavior changes in the following way. Instead of buying 5 hamburgers now, he reduces his hamburger consumption to 4. This tells us the slope of the line, the rise over the run. The rise in this case is the change in the y variable, which in this case is an increase in the price of the hamburger by 50 cents. And the run is the change in the x variable. How does Bob's behavior change? And in this case, he reduces his hamburger consumption from 5 to 4. That is a change of negative 1. So if we wanted to calculate the slope of this line, we would divide the rise by the run. That is, in this particular case, the slope is going to be equal to 50 cents divided by negative 1 hamburgers, or negative 50 cents. Negative 50 cents is the slope of the line, and that's what you see right here in the formula. So, for a straight line, the important terms are the vertical intercept, which shows up right here as this constant term, and the slope of the line, the rise over the run, which shows up as the coefficient on this variable. In this particular case, it's the coefficient on the quantity of hamburgers, negative 50 cents. Every straight line can be characterized by these two